Hello everyone, and welcome to a short demonstration of the use of the PerkinElmer FT-IR. The instrument is housed in a room adjacent to the OChem lab, which is right in there. There's only one FT-IR, so that means we have 8 students. Because of social distancing, only one student can use the instrument at a time. So you just check the window. If there's no one in there, then you're welcome to enter the room and run your sample. All right, so the front of the instrument looks like this. It has an accessory called an ATR, for attenuated total reflectance. And that enables you to analyze very small samples. In fact, looking carefully at the instrument, this is called a force gauge, by the way, and I'm going to swing this over. This is where your sample is placed. So you don't need much sample. If it's a liquid, 1 drop will be enough. If it's a solid, just enough to cover. It looks like an opening. It's not an opening. There's a zinc selenide plate. That's what you're looking at, and that's what you have to cover with your solid sample. The first thing you do before you even use the instrument is to check to make sure it's clean. I'm going to swing this over here so you can get a better look at the plate. So this is referred to as a force gauge. Notice there's a distance between the force gauge and the top of the plate. You never want to move this when this is pressing down on the plate. Now, clockwise lowers the force gauge. Counterclockwise, just think of the dial of a clock, raises the force gauge. If you're in doubt, just take a look at the opening here, and you see how it's dropping down. I'm lowering the force gauge. I'm going in a clockwise direction. I'm raising the force gauge. Counterclockwise. You never want to move this if it's in this position, because you will scratch the plate. And you can see scratch marks where students have not been careful. So please be careful when you do this. If you scratch the plate, that will affect the analysis. If you scratch or damage the crystal, we'll have to replace it. And that's expensive. It's about $5K. So you don't want your parents getting a bill for $5K because you weren't careful. Okay, so the first thing, before you use the instrument, we're going to ensure that this area is clean. I've got a little bit of alcohol. Out of the way. Sorry about that. All right, denatured alcohol. Yes, the word denatured is important because this is toxic. So you want to be handling gloves. You don't want to get this on your skin. Obviously, you don't want to ingest it. They have added chemicals to this to make it poisonous, right? So, you can't drink this. And that's what the word denatured means. So as soon as you see the label denatured, be more careful than you would be if it were not denatured. Okay, so a few drops of this on a chem wipe will do the job. And there's a dropper in here, so it's easy. Just a few of these. Of course, I've got to put this down. A few drops on a chem wipe, and just swab the surface. Not difficult. Now you know that's clean. Even if you can't see anything, there may be a residue there which is transparent. And the other thing that you have to do is remove this. This pops off. If I pull down, isn't that nice the way that kind of drops off? And see the surface? Nice and clean. I'll swab it anyway to make sure. But you can see there's no solid. I'll show you a little bit later on where solid will adhere to this. And of course, if you don't check it, then when you run the spectrum of your solid, whatever was last on here is the spectrum that you're going to get. Okay, this simply tension is what holds this. There's a little O-ring there. That's back on there. It's not dropping off. This is secure. Now we're ready to log into the computer. We know that the sampling compartment, if you want to call it that, is clean and free from any contamination. Let me go ahead and share the screen for you. So you're going to log into the computer just like you would log into any Mercyhurst computer. with your login information, password, and this is what you will see. The program that we want is called Spectrum IR. Double click, you're an FTIR user. Takes about 30 seconds. And there's the screen that you will see. This is where the spectrum is acquired. There's a y-axis, which is the percent transmittance, or if you want absorption, it could be the percent absorption. It doesn't matter which axis you use. And you can change that by looking at the icons here. I know there's a lot of icons. It looks complicated. We're going to do a very simple acquisition for the first few labs, and then there'll be a little bit more detail later on. But for now, if you want absorbance, click on this. If you want percent transmittance, either one is going to work. Click on this. And now we're going to acquire a spectrum. Now it's a solid, so what we have to do is ensure that we've got enough pressure. If you look at the insert, you ought to be able to see that pressure gauge, the force gauge. So we're going to have to increase the pressure on your sample to get an acceptable spectrum. But I want to monitor the pressure, and we do that by clicking on the monitor. However, first we're going to have to obtain a background. So before we do anything, the first thing you do after opening up the software is to click on background. It says scanning, background. That's like a blank, if you remember from general chemistry, right? So we're getting a good baseline before we start the acquisition of your solid sample. You notice there's a button up here that says halt. That means it's collecting data, it's doing something. So if you tried to exit the program, you would not be able to exit the program as long as this halt button is active. Now you see it's gone, so now we can go ahead and scan. But I want to monitor before I put my sample on the plate. So I'm going to click the monitor. And now it gives you the pressure from the force gauge, the current, which you don't have to worry about. So these two you don't have to worry about. This is what you want to focus on. So I want to add sample to the plate. So let me stop share, get back to this. I think this is caffeine. A few crystals, that's all I need. So we'll get a view here that hopefully you can see easily. A couple of crystals from here. You see, that's more than enough. On top, notice that I'm not scratching anything with the tip of this spatula. Put the lid back on. Whenever you use something, always remember to put the lid on when you're done using it. Swing the force gauge, right? You can see the distance between the force gauge and the top of the plate. If I raise it up or lower it, right? But I have a nice distance to work with. Swing it over, and now you're going to lower the force gauge. So that means what? Clockwise direction. And let's go back to monitor so you can see that. So let me go back to share screen, share. And in the insert, you should be able to see me lowering and doing a clockwise, and look what happens with the force gauge. You'll feel the tension. Isn't that nice? That's just enough pressure. So you know when you have enough pressure by having the force gauge up and running. So always have that force gauge visible when you start to go clockwise or counterclockwise, when you start to change this. That'll tell you you're going in the right direction. Now, if you put a little more force on there, it's not going to change the spectrum. So green says I've got enough force on the gauge. One thing you don't want is red, and that occurs later on if you put too much pressure. But as long as you stop at this point, you will not have a problem. So let's go back. And now we're ready to scan the sample. So I'm going to click scan. I know that I have enough force on there. And notice it says previewing. When you scan a spectrum using the FTIR, it always allows you to preview the spectrum. So if it doesn't look right, if you want to change something, if you forgot to put any force on it, of course you know there's force because if you look down here you can see it. But if you forget something, this allows you to change it before you actually acquire the spectrum. So it's a nice thing to have. Okay, so there's still previewing. It looks good. I mean, I see a nice little noise in the background here. The peaks look nice and sharp. That looks great. So I'm going to go ahead. This looks acceptable. I'm going to go ahead and scan this. "10 seconds, maybe 15 seconds. It used to take 15 minutes. I kid you not. It used to take 15 minutes to run a spectrum using an FTIR. And I'm looking back maybe 20 years. Yeah, so a lab of 8 students, you can just think about how much time it would take each student to acquire a spectrum. So there it is. There's your FTIR spectrum. We can, if you look at these icons down here, one of them will say cursor. If you click on this, that gives you a cursor, and I could move this. I can move it back and forth, and that will tell me exactly where the signal absorbs, exactly what frequency of radiation is being absorbed on the bottom axis. See, it says 1293, and here it says, what, 1454. So it'll tell you what the frequency is. We don't need a cursor. There's an easier way to do that. I'm going to apply a label. So clicking on the label automatically applies a label to each one of the signals above a certain transmittance or absorption. So there's a cutoff here which you can set. So you could set this such that you would see the first 20 signals, or you would see all signals above an absorption of X. All right, that looks pretty good. A few other things we can do with this spectrum is we can, if you think this is the absorption of a carbon-carbon double bond, you can actually put that in there. You can actually add text. So if you go to, let's see, add text. So it's going to be in the view, add text. Isn't that nice? And so we can put, if you think that's a carbon-carbon double bond, we can put that in there. So wherever you think a carbon-carbon double bond comes, you can add a label. You can also add a label for a carbon doubly bonded oxygen, or for a carbon singly bonded oxygen. So all of these signals are significant for certain bonds: carbon oxygen, carbon fluorine, carbon double bond oxygen, carbon double bond carbon, benzene ring. They're all characteristic frequencies for the absorption of that particular bond between particular atoms. Okay, so we've labeled this. The last thing you're going to do is to save the spectrum. So we're going to go over to File, and we save it by doing a print. And we're going to print as a PDF. This will be beautiful because you can add this to your laboratory report. We'll go ahead and print this as a PDF, and now is where you can put your name and the date. I think this is caffeine. You could also put the lab, experiment number 2 or lab 2. Save this. Nice looking spectrum, very professional in terms of the outlay of the spectrum. You can email this to yourself, or if you save it to your personal cloud, it should be available to you, because all of this, of course, is on the internet. We're almost done. The last thing I want to do is to remove the pressure on the gauge. So I want to get back to the force gauge before I do anything, because if I turn the wrong direction, I'm going to be increasing the pressure instead of decreasing the pressure. So I want to go back to the force gauge. And now, obviously, I went in the correct direction because you can see the pressure disappear. I'm going to raise this a little bit. I want to raise this off the instrument. So let's go back to there we go. All right, so before I move this, I'm going to raise this up enough. You see that? So you can see it. Now there's no way you're going to scratch the surface. So make sure you do that before you clean the surface. Now I can move this out of the way. I can take my chem wipe, a few drops of alcohol. And by the way, this is a non-destructive method. If you have ambitions of working in a crime lab, you know that most of the methods in a forensic lab have to be non-destructive in case you want to reanalyze the sample. So I could actually collect the sample. If it were an illicit drug, I could collect it, put it in the vial. But for now, I'm not going to collect the sample. But, you know, some compounds, you know, it takes 3 or 4 weeks to synthesize the compound, and you're looking at spending tens of thousands of dollars for the preparation. So in this case, the chemist will want to save the sample, not simply soak it up with ethyl alcohol and dispose of it. All right, that looks pretty good. What have I forgotten to do? Hopefully you said, check this. So let's check that. How about that? Isn't that amazing? There's enough stickiness that this will adhere to that. If you don't clean that, the next student that comes in is going to get the spectrum of, what was this, caffeine? So again, a little bit of alcohol in your chem wipe. Make sure the surface is clean. Looking pretty good. Okay, so we've cleaned the apparatus. Looks good. The last thing we're going to do is, of course, log out, right? So we're going to, let's see. I don't want to exit the meeting yet. Let's go ahead and share screen. Okay, so we can close the program. Cannot be edited. Aha! So hopefully you know what went wrong. What button is still illuminated? See that? So it's still real time looking at that zinc selenide plate. So let's close that out. Now we can exit the program. I'm going to exit without saving any data sets. And now you're going to log off the computer. Don't forget to log off. If you don't log off, the next student in is going to have access to your website. So log off of the computer. And we're done. So that's the demonstration on the analysis of a solid sample.